Hello everyone, myself Dr. Pradeep Kumar MR, working as Assistant Professor in the Department of Pharmaceutical Chemistry at Kelly College of Pharmacy, Hubli. In this session, I will be discussing on the topic preservatives. First, the definition. Preservatives are compounds or agents that are added to various pharmaceutical dosage forms and cosmetic preparations to prevent or inhibit microorganism growth. Need for preservatives. First, for the protection of drug and cosmetic from microorganism attack. Second, to increase shelf life of product. Third, to maintain the activity and efficacy of the drug or cosmetic till it reaches the end user. And finally, to provide stability to drug or cosmetic. Coming to the ideal characteristics of preservatives. An ideal preservative should have the following characteristics. First, it should be effective at low concentration. Second, it should be cost effective. Third, it should not interact with other constituents of formulation. Fourth, it should be non-irritant. Fifth, it should be non-toxic. Sixth, it should be physically and chemically stable. Now we will see some preservatives which are commonly used in drugs and cosmetics. Amongst that, the first class is of para-hydroxybenzoic acid derivatives. Examples include methylparaben, ethylparaben, propylparaben, and butylparaben. This is the structure for methylparaben. This is the structure for ethylparaben. This is the structure for propylparaben, and this is the structure for butylparaben. Esters of para-hydroxybenzoic acid, which are also known as parabens, are very much preferred as preservatives for liquid dosage forms. The preservative activity generally increases with molecular weight, but the methyl ester is most effective against molds and propyl ester is most effective against yeasts. Propyl ester, being more lipid soluble, is much preferred as preservative in oil or lipophilic bases. Coming to the second class, there is benzoic acid and its derivatives. Example includes benzoic acid, sodium benzoate, and sodium propionate. This is the structure for benzoic acid. This is the structure for sodium benzoate, and this is the structure for sodium propionate. First, the benzoic acid. It is effective as preservative in pharmaceutical products at low pH. In emulsions, when used as preservative, its effectiveness depends on both pH and distribution into the two phases. Next, the sodium benzoate. As preservative, it is used in acidic liquid preparations. Next, the sodium propionate. It is effective as preservative at low pH. Next, another two examples are sorbic acid and potassium sorbate. This is the structure for sorbic acid and this is the structure for potassium sorbate. Coming to the sorbic acid, chemically it is 2,4-hexadinoic acid. It is used in syrup, elixirs, ointments and lotions which are more prone for mold growth. Next comes phenyl mercuric nitrate and phenyl mercuric acetate. This is the structure for phenyl mercuric nitrate and this is the structure for phenyl mercuric acetate. Coming to the phenyl mercuric nitrate, it is a mixture of phenyl mercuric nitrate and phenyl mercuric hydroxide. It is used in 1:10,000 to 1:50,000 concentration in injectable to prevent bacterial contamination. The only disadvantage associated with this is its efficiency is reduced in presence of serum. Similarly, for phenyl mercuric acetate, it is also used in 1:10,000 to 1:50,000 concentration in injectables to prevent bacterial contamination. Coming to the other preservatives, examples chlorobutanol, benzyl alcohol, phenyl ethyl alcohol. This is the structure for chlorobutanol. This is the structure for benzyl alcohol and this is the structure for phenyl ethyl alcohol. Coming to the chlorobutanol, it is used in injection and ophthalmic preparations. It is very much stable in oils. Next, the benzyl alcohol. It is used as preservative in vials of injectable drugs in 1 to 4% concentration in water or saline solution. Next, phenyl ethyl alcohol. It is used in cosmetics, mainly in perfumes. Coming to the next compound, that is benzalkonium chloride. This is the structure of benzalkonium chloride where N may be 8, 10, 12, 14, 16 or 18. It is a quaternary ammonium compound. It is used in ophthalmology since 1940. It is found in more than 70% of eye drops. It acts by lysing cell membrane of microorganisms, thereby ultimately killing them. The next compound is alpha tocopherol. This is the structure of alpha tocopherol. They are the methylated phenols, natural mixtures of tocopherol consists of alpha, beta, gamma and delta isomers, amongst which alpha form is more effective. By preventing the growth of microorganisms, they maintain the freshness and shelf life of products. After knowing about the preservatives, it is very much required to know some frequently asked questions on preservatives. Here are few. First, define preservatives. Give one example. Second, write the structure and use of methylparaben and chlorobutanol. Third, write the structure and use of alpha tocopherol and benzyl alcohol. Fourth, write the structure and use of benzalkonium chloride and sodium benzoate. Fifth, write the structure and use of phenyl mercuric nitrate and phenyl mercuric acetate.